Nikos Kazantzakis, among the most popular Greek writers in the past century, famously said, "There is only one woman in the world, one woman with many faces." Most things around us has many facets. Trigonometric functions are no exception. We shall revisit the other faces of the three primary trigonometric functions: the sine, the cosine, and the tangent. Expect trigonometry to endlessly surprise in its expanse. The backdrop is how the school years unfairly ground trigonometry to triangles, limiting the very thought around it. The many faces of trigonometric functions present another level of surprise, depth, and possibilities in generating newer meanings and dimensions of things. To be brief, the three trigonometric functions have inverses, and they also have inverses of their multiplicative inverses. Thus, three functions create 12 different functions. Let us get to the 12th. In the previous lesson, we had acquainted ourselves with the functions called cosecant, secant, and cotangent as the multiplicative inverse of the functions sine, cosine, and tangent. For example, the cosecant function applied to one of the acute angles of a right triangle will output the ratio of sides, the hypotenuse to the side that is opposite to that angle. This ratio is the multiplicative inverse of the ratio obtained by applying the sine function on the same angle. The sine function will output the ratio, the same opposite side to the same hypotenuse, that is, just the inverse ratio of cosine. The use of cosecant, secant, and cotangent expand the arithmetical power of trigonometry, making the inverse of the ratio of sides as directly usable quantities and in more convenient notations. For example, we may not use 1 by sine x in computations and instead use cosecant x to mean 1 by sine x. This often simplifies computations. Just to reinforce, multiplicative inverse of a number is that number which, when multiplied by the first, has 1 as the product of the multiplication. We had also registered that an inverse function is like the antifunction of the function it is inverse of. It would take the output values of the original and returns the input values of the original function. Inverse functions are also functions in every sense. For example, the inverse of the sine function of an acute angle will take a ratio of sides, that is the sine's ratio, opposite side by hypotenuse, to output the corresponding angle. The inverse of trigonometric functions are extensively used. They have direct applications. For example, if we are to find the angles, when ratio of sides is accessible, we directly feed the ratio of sides in the appropriate inverse functions. A comparative on the inverse functions, such as sine inverse, and the multiplicative inverse functions, or reciprocal functions, such as cosecant, may be helpful. Inverse functions give us newer mathematical relationships, such as ratio to angles. In the process, they present newer applications, newer mathematical language, etc. Multiplicative inverses do not offer newer relationships. They mostly simplify trigonometric expressions or computations. Here is the more detailed animated summary of trigonometric functions and their inverses. Sine is a trigonometric function of an acute angle which gives the ratio of sides opposite to by the hypotenuse. Sine inverse is the inverse trigonometric function that operates on the same ratio as the sines, opposite by the hypotenuse, to give the angle. Cosine is a trigonometric function of an acute angle which gives the ratio of sides, adjacent to by the hypotenuse. Cosine inverse is the inverse trigonometric function that operates on the same ratio as the cosines, adjacent by the hypotenuse, to give the angle. Tan is a trigonometric function of an acute angle which gives the ratio of sides, opposite to by adjacent to. Tan inverse is the inverse trigonometric function that operates on the same ratio of sides as the tans, opposite by adjacent, to give the angle. Cosec is a trigonometric function of an acute angle which gives the ratio of sides, hypotenuse by opposite. Cosec inverse is the inverse trigonometric function that operates on the same ratio of sides as the cosecs, hypotenuse by opposite, to give the angle. Sec is a trigonometric function of an acute angle which gives the ratio of sides, hypotenuse by adjacent. Sec inverse is the inverse trigonometric function that operates on the same ratio of sides as the Sx, hypotenuse by adjacent, to give the angle. Cot is a trigonometric function of an acute angle which gives the ratio of sides, adjacent by opposite. Cot inverse is the inverse trigonometric function that operates on the same ratio of sides as the cots, adjacent by opposite, to give the angle. Hope this summary settled the subtle difference between inverses and multiplicative inverses. Sec inverse is the inverse trigonometric function that operates on the same ratio of sides as the secs, hypotenuse by adjacent, to give the angle. Cot is a trigonometric function of an acute angle which gives the ratio of sides, adjacent by opposite. Cot inverse is the inverse trigonometric function that operates on the same ratio of sides as the cots, adjacent by opposite, to give the angle. Hope this summary settled the subtle difference between inverses and multiplicative inverses. Here are a few examples of how the functions and their inverses work. A trigonometric function, when applied to one of the two acute angles, gives the corresponding ratio of the length of sides of the right triangle. Whereas an inverse trigonometric function, when applied to a ratio of the sides of a right triangle, gives the measure of the corresponding acute angle. The output of a trigonometric function is always a ratio, which is a numeral, a unitless quantity. The input is always angles. What it implies is that these ratios are not the ratio of actual lengths of the sides. They represent the ratio of actual lengths in the simplest form. That is how ratios are written, because we use ratios to express the comparative magnitudinal relationship of quantities, not absolute. For example, 5 by 10 will be written as 1 by 2 in the ratio form. But then, how can we know the actual length of sides, given the ratio of the sides? There is just one way. We need to know the actual length of at least one of the sides. And then, we can use the ratios to get the actual length of the other sides. This is a very important aspect of knowing trigonometric functions. And perhaps the most important reminder out of this discussion on ratios this: in an earlier lesson, we had witnessed an animation that showed how the ratio of sides is always the same for a given acute angle in a right triangle. This is one foundational property of trigonometry. Actual length of sides is not important. It is the relative length in relating sides and angles. On the other hand, the output of an inverse trigonometric function is always an angle, which is a number, a quantity with unit. Angle is a measurement, and thus ought to have a unit of measurement. As yet, we know that unit as degrees. Degree, as a measure of rotation, is defined in a way that one full rotation is considered to be 360 degrees. So 1 degree is one part of the 360 parts of the extent of rotation around a point. An angle is a measure of rotation around a point called vertex. Every angle has two arms, two straight lines, joined at the vertex. One arm stays and the other moves. The extent of movement of the other arm is stated as the angle made by two straight lines at the vertex point. Every ratio of sides of a right triangle represents a unique trigonometric function. But only 3 distinct ratio expressions are possible with the 3 sides of a triangle. That explains the 3 primary ratio of sides and the 3 primary functions in trigonometry: sine, cosine, and tan. Recall, the sides have different meanings for each angle. Expectedly, sine, cosine, and tan have different meaning for each of the acute angle in a right triangle. No less, there are angles and there are sides. In trigonometry, we have chosen to call the relationship of angles to the ratio of sides as functions, and the relationship of ratio of sides to the angles as inverse functions. Thank you. With us, you will master all the mathematics you need. Be good to you, not just others.